71% of our planet is covered by water. We have mapped the surface of Mars. We have photographed galaxies 14 billion light-years away. We have sent probes beyond our own solar system. But as of right now, we have explored less than 27% of the ocean floor in any meaningful detail. Less than 1/10 has been seen up close. The deepest, strangest, most alien environment on Earth is right here, beneath our feet. And we know almost nothing about it. Here is the number that should stop you cold. 71% of Earth's surface is ocean. And of that ocean floor, 73% has never been mapped at modern resolution. Think about what that means. Most of our own planet is a blank. The Seabed 2030 project, a global effort backed by UNESCO, confirmed that as of June 2025, we have mapped just 27.3% of the world's seafloor to a meaningful standard. When the project launched in 2017, that number was 6%. Meanwhile, NASA has imaged 99% of Mars's surface. The moon has been mapped at 7-meter resolution, finer than most city maps. We know the topology of Mercury, Venus, Jupiter's moons in extraordinary detail. Our own ocean floor, a blur. The reason is surprisingly simple and almost embarrassing. In space, we use light, radar, electromagnetic waves. They travel perfectly through vacuum, but water kills them. Light barely penetrates 200 meters into the ocean. Below that, it's complete darkness. The only technology that works underwater is sonar sound waves, and sonar-based mapping requires a ship to physically sail above every square kilometer of ocean, one pass at a time. World's ocean covers 360 million square kilometers. At current rates of survey, it would take more than 50 years to map it all. The cost to map the entire ocean floor, approximately $3 billion, less than a single Mars mission. The money is not the barrier. The will is. The Mariana Trench. In the western Pacific Ocean, a gash in the Earth's crust so deep, it would swallow Mount Everest with 2 kilometers to spare. Lowest point, called Challenger Deep, sits 10,935 meters below the surface. To put that in terms your body understands, the pressure at that depth is 1,086 times the atmospheric pressure at sea level. Every square centimeter of any object down there bears 8 tons of force. The temperature hovers just above freezing, 1 to 4 degrees Celsius. Pitch black, silent, crushing, and yet life exists there. In 1960, 2 men, Jacques Pickard and Don Walsh, descended in a steel sphere called the Trist. The trip down took 4 hours and 47 minutes. They spent just 20 minutes on the bottom. They saw a flatfish, which meant life finds a way even in hell. Since 1960, only 5 people have ever reached the deepest point in the ocean. 5. Compare that to over 600 who have been to space. James Cameron, the director of Titanic and Avatar, made the solo dive in 2012 in a submersible he designed himself. He spent 3 hours exploring the bottom and described it as a desolate, empty lunar-like landscape. Then in 2019, explorer Victor Vescovo descended to 10,928 meters, the deepest human dive ever recorded at that time. He found a plastic bag and a candy wrapper. At the bottom of the ocean, the deepest point on Earth, already polluted. The ocean is so vast, so unknown, and humanity has already left its mark on the parts we've barely visited. In the deep ocean, where no sunlight reaches, life has evolved an extraordinary solution: bioluminescence, the ability to generate its own light. 76% of all organisms observed in the deep ocean can produce light through chemical reactions in their bodies. Not just a few creatures, not a novelty. 3/4 of all deep-sea life glows, and yet we have almost never seen it. Because getting a camera down there, undisturbed, in full darkness for long enough remains extraordinarily difficult. Researchers at MBARI spent over 25 years collecting observations across 1,700 dives before they could quantify this. What else is down there that we haven't seen? Scientists estimate that 91% of all ocean species remain completely undescribed, unnamed, unknown. In 2024 alone, over 100 new species were discovered off the coast of Chile. In 2025, 24 new species were found in a single deep-sea zone in the Pacific. We are still finding entire branches of the tree of life in our own ocean. In 1977, scientists discovered something that rewrote the story of life on Earth. Deep in the Pacific, along a crack in the ocean floor called the Galapagos Rift, they found chimneys, hydrothermal vents, towers of superheated water reaching 400 degrees Celsius erupting from the ocean floor. The water should boil, but under that pressure it doesn't. And around these chimneys, life: enormous tube worms, blind shrimp, white crabs. An entire ecosystem with no sunlight, no photosynthesis. Instead, chemosynthesis. Bacteria at the base of the food chain using hydrogen sulfide to create energy. Before 1977, scientists believed all life on Earth ultimately depended on the sun. That assumption turned out to be wrong. Today, these hydrothermal vents are considered the most likely birthplace of life on our planet, because they provide exactly the conditions needed for the first chemical reactions that could produce living cells: heat, minerals, chemical gradients, and no need for light. If life began at a hydrothermal vent on Earth, it may be beginning right now at similar vents beneath the ice of Jupiter's moon Europa, or Saturn's moon Enceladus. The deep ocean did not just change oceanography, it changed astrobiology. It changed our understanding of where life can exist in the universe. The ocean floor is not just scientifically important, it may be the most economically valuable real estate on Earth, and almost no country has laid claim to it yet. Japanese researchers have mapped 100 billion tons of rare earth minerals in Pacific Ocean sediments. Clarion-Clipperton Zone, a vast stretch of the Pacific seafloor, contains 21 billion tons of polymetallic nodules. Lumps of nickel, cobalt, manganese, and copper sitting on the ocean floor in concentrations higher than all known land reserves combined. Total estimated value of seabed mineral resources, between $8 and $16 trillion. These are the same minerals needed for rechargeable batteries, smartphones, electric vehicles. In the green energy transition, the International Energy Agency projects global demand for these minerals to increase sixfold by 2040. The race to mine the deep ocean floor has already begun. 22 commercial licenses have been issued in international waters, but scientists warn, we don't know what we're destroying. We haven't mapped the ecosystems down there. We haven't cataloged the species. We're about to industrialize a world we've never even visited. Every breath you take is partly the ocean's gift. The ocean absorbs 31% of all carbon dioxide released into the atmosphere, 38 million tons of CO2 every single day. Without the ocean, the greenhouse effect would be catastrophically worse. The deep ocean floor plays a critical role in this process. Cold. Then seawater sinks from the surface, carrying dissolved CO2 to the depths, where it can remain locked away for centuries or even millennia. Dead organisms and carbon-rich particles rain down from the surface, settling into sediment at the bottom. This is called the biological carbon pump. It has kept Earth's climate stable for millions of years. But recent research shows that the ocean's ability to absorb carbon may be weakening. Warmer surface temperatures disrupt circulation patterns. Ocean acidification, caused by absorbing too much CO2, is threatening the shell-forming organisms at the base of the marine food chain. The deep ocean is not just an alien world. It is a system we depend on that we barely understand, that we are already damaging. Before the Cold War, ocean exploration and space exploration had roughly equal funding and roughly equal progress. Both were frontiers, both were unknown. Then the space race changed everything. Putting a man on the moon became a symbol of national power. Funding flooded into NASA. The military saw strategic value in space. The ocean remained not dramatic enough, not fast enough, not politically useful enough. We chose the stars over our own backyard. Today, NASA annual budget is around $24 billion, the total global investment in ocean mapping. A fraction of that, 5 humans have visited the deepest point in the ocean. Over 600 have been to space. We have detailed, high-resolution maps of bodies that are hundreds of millions of kilometers away. And the floor of the ocean, 2 kilometers beneath a ship floating in international waters, remains largely unseen. This is a choice, not a technological limitation. A choice. The Seabed 2030 project has set an ambitious goal to map the entire ocean floor by the year 2030. As of 2025, they have reached 27%. At the current pace, it will take far longer than 5 years to finish. But momentum is building. New autonomous underwater vehicles, OV, can now map ocean floors without a human crew. Satellite altimetry, measuring tiny variations in sea surface height caused by gravity anomalies from underwater mountains, can provide rough maps from space. MIT researchers unveiled a new surface-based sonar system in 2024 capable of dramatically accelerating high-resolution mapping. The technology exists, the will is growing, and what we find when we finish the map will almost certainly change everything. New species, new geological structures, new mineral deposits, new clues about Earth's formation, new evidence about the origin of life, perhaps instructions for how to save the climate. The deep ocean is not just a mystery. It is a library unread beneath 3 kilometers of water. 71% of Earth is ocean, most of it unseen. Under that water, ecosystems we cannot imagine. Minerals worth more than all land reserves combined. Possible birthplace of all life on Earth. Clues about how to stop climate change. New medicines, new species, new understanding of who we are and where we came from. We chose to look at Mars first. We chose space over sea. That choice shaped what we know and what we don't. But the ocean is still there, patient, dark, waiting. And the clock is ticking because we are already changing it, mining it, warming it before we have even seen it. What do you think lives at the bottom of the ocean that we still haven't found? Comment below and follow Fact Forge for more facts that make you question everything you thought you knew about this planet.